Hey Gators, this is trig functions, and this is going to be done in 3 parts. The first part will be discussing radian measure and the 6 basic trig functions. Let's first talk about what a radian is. It's a way to measure an angle, and a radian is, 1 radian represents how much you have to open up the angle so that the arc length here inside the angle is the same as the radius, and that's called 1 radian. Radian measure is defined to be the arc length, this length right here, divided by the radius. And when you take this length and divide it by the radius, we view that as the angle, the radian measure. If you remember circumference formula, C equals 2 pi r, and 2 pi is about 6.28 radii. So there are about 6 radii that go all the way around the circle. If you just want to do half a circle, it would be 3.14, 3 radians, and 0.14159 radians. So we say pi radians is equal to 180 degrees. So a semicircle is 180 degrees. If you want 90 degrees, then divide it by 2, both sides. If you want 1 degree, it's pi over 180. And if you want 1 radian, it's 180 over pi. Let's go back to some geometry. In a 30, 60, 90 triangle, or a 30-degree angle is pi 6. This is the ratio that we taught you in geometry. I'd like you to consider this hypotenuse being 1, and when it's 1, we're going to be working with a unit circle. So in order for this to be a length of 1, we're going to divide all sides by 2. And so these are the 3 sides of a 30, 60, 90 triangle with a radius of 1. Let's take a look at a 45, 45, 90. These are the numbers we taught you in geometry. Let's go ahead and make this hypotenuse 1, so we're going to divide everything through by root 2. This is the unit circle with a 45 or pi force angle. Let's look at again, the 30, 60, 90 triangle, and this is a 60-degree angle, or what we call pi thirds. We'll go ahead and go to the unit circle, and these will be the numbers. When we're talking about a unit circle, there are really, for our special angles, there are really just 5 numbers to look at. 0, 1/2, root 2 over 2, root 3 over 2, and 1. And these are order in increasing order. Cosine in geometry was adjacent over hypotenuse. Remember, the hypotenuse is 1, so the adjacent right here is the x-coordinate. Sine in geometry was opposite over hypotenuse, and the opposite in this triangle will be a y-coordinate. So that's how we see that. Now look at the 5 numbers again. Right down here, this is 1, 0, x is 1, or the cosine, y is 0, or the sine of the angle. Sine of 0 is 0. When we go to pi 6, notice that the sine is the y-coordinate, and that is 1/2. That is a short length, and this x-coordinate right here is long, and so that would be root 3 over 2. So if you can keep those kinds of things in mind, that will really help. Again, one more time, the x-coordinate is used as the cosine of the angle that has to be in radians, and y is the sine of the angle as long as the angle is in radians. Remember on the quadrants that x and y are both positive in the first quadrant. X is negative, y is positive. All these are important to keep in mind. Let's go ahead and do some problems. I want to figure out the cosine of this angle. And so I want you to think about it. This is pi force. And remember, the pi force means that these 2 sides are the same. Remember the 3 numbers, 0, 1/2, root 2 over 2, root 3 over 2, and 1. And this one is always for the pi force angle. And so that means these both lengths are the same, so the answer is root 2 over 2. Let's go ahead and go over here. Let's draw a triangle. This is pi force, which means that that the reference angle is pi 4. So we're working with this kind of measurement. They're both the same. We're asking for the sine, and the sine is the y coordinate here. The y is negative root 2 over 2. Over here on tangent, let's go ahead and take a look at the triangle. This is 4 pi thirds, which means the reference angle is pi thirds. Pi thirds means that the y is the longest one, so this will be negative root 3 over 2. And the x, or the cosine, will be negative 1/2. And tangent is, remember, opposite over adjacent, or sine over cosine. This will be negative root 3 over 2, and this will be negative 1/2. Now we can get rid of this dividing by 2 by multiplying numerator denominator by 2. So this will reduce, and the answer will be root 3, because a negative divided by negative is a positive. Okay, over here, this point right here is 0, negative 1. And so again, we're going to do sine over cosine. So this is the sine of theta over the cosine of theta. And sine of theta is negative 1, cosine is 0. And so this one will be undefined. So the tangent here is undefined. Let's go ahead and continue over here at 2 pi thirds. This is going to be the long leg, which is root 3 over 2. This is going to be the short leg, which is negative 1/2. We will want the x coordinate, which is negative 1/2. Over here, this is the reference angle is pi 6. That means the long leg is here. So this is root 3 over 2. And that's our answer, root 3 over 2. We don't want the short leg. We want the long leg, because that's the x coordinate. Here I'm looking for the x coordinate again. The x coordinate is going to be long, which is negative root 3 over 2. And so that's negative root 3 over 2. And over here, our short leg here is negative 1/2. Our long leg here is the x coordinate, which is negative root 3 over 2. We're going to do sine over cosine, so this will be over this, and that will end up being 1 over root 3. You can leave it that way, or you can write it as root 3 over 3. Okay, I'd like you to try. It's important that you be able to do this. Stop the screencast and see what you can do. And here are the answers. Go ahead and stop the screencast, see what you can do. And here are the answers. Let's go on to all 6 ratios. We spent time on the sine, cosine, and tangent. The cosecant is a reciprocal of sine. The secant is a reciprocal of cosine. The cotangent is a reciprocal of tangent. And here's the reciprocal showing up again, and there's tangent and cotangent in terms of sine and cosine. The sine graph represents the y-coordinate as it goes from 0 to pi. So when we start here on the unit circle, you can see the sine gets larger and larger. So that's why the curve is going up. As it goes into the second quadrant, the unit circle, the y-coordinate gets smaller and smaller till it gets to 0. And then as it goes around, the y-coordinate is getting more and more negative, which is happening right here. And then the y-coordinate becomes closer and closer to 0, and that's what we see right here. And then it repeats itself as it goes around again. The same idea is true for the cosine, but this time you're looking at x coordinates. And the x coordinate right here is very long, and as it goes around, as the angle gets bigger and bigger, it becomes smaller and smaller. And so the wave is still there, but it starts at a different place. Tangent is, remember, sine over cosine. So we have a problem when this is going to be sine of x over cosine of x. And we're going to have a problem when the cosine is 0. And the cosine is 0 at these places, pi halves, negative pi halves, negative 3 pi halves, and so on. So this is going to have asymptotic behavior. Here's cotangent. Now if we go back here to tangent, everywhere that there is where the tangent is 0, right here, these reciprocals are going to be our asymptotes for our reciprocal function. And you can see right here, these y values are very small. The reciprocals will be very large. Over here, these large y values will be very small as they become reciprocals. So that's why you see what happens there. The cosecant, remember, is the reciprocal of sine, and so we are going to have a problem every time sine is 0. Here, here, and here, and you can see these are the spots where we have the asymptotic behavior. And again, this y-coordinate is 1. Its reciprocal is going to be 1. As these y-coordinates become, as these y-coordinates here are become reciprocals, the smaller the value, the reciprocal, the larger it is. So that's why we have these scoop looks right here. Same thing happens for secant when it's the reciprocal of cosine. Right here is a list of all the domain and ranges for the sine and cosine. Remember that sine and cosine are continuous functions. They don't stop, but all of these tangent, cotangent, secant, and cosecant have vertical asymptotes.